Good evening, Senior 1. Nice to meet you again in physics. We are still on our topic, that is force. And under force, I left some research work and assignment for you. Which assignment did I leave with you? Good. The assignment which was left with you is to get the information about mass. You get the information from weight, then you use that information to get the differences between mass and the weight. So which information did you get about the differences between mass and the weight? One has said that one of the difference, we get the difference from the SI units. How do we use SI unit to differentiate between mass and the weight? Good. One of your colleagues, from what I checked, said that the SI unit of mass is kilogram, while the SI unit of weight is Newton, which was very correct. However, some gave that the SI unit is gram. No, SI unit of mass is a kilogram, though we have another unit for mass which is gram. From gram and kilogram, the SI unit is kilogram. So we have mass and weight. We are getting the information, mass and weight. One said here SI unit is small k, small g, that is the kilogram. Then on the other side, SI unit is Newton, which is capital N. That one was very correct. This one for gram. Gram is a unit of mass, but it is not SI what? SI unit. Then another information which I got, the response which I got from you. Another one said that we can differentiate between mass and weight using what? Using the instruments which are used for measuring mass. So I have the instrument here. What is the name of this instrument? What is the name of this instrument? Good. One has said it is a beam what? A beam balance. What do we use this instrument for? This instrument, it is used for measuring what? Which mass and weight? Which one does it measure? It is used to measure mass. What about this instrument? What name is given to this instrument? Look at it. What name is given to this instrument? Good. This is called a spring what? A spring balance. Under weight and mass, which quantity does it measure? It measures weight. Therefore, we can use those two to differentiate. We see that this is, one has said that this is a beam what? This is a beam balance. This is what? This is a spring what? Spring balance. The spring balance is used to measure weight. And the beam balance is used to measure mass. That is great. We can use the instruments to differentiate between mass and weight. Here we have said it is measured using what? Using a beam what? A beam balance. That is a very good answer. Beam balance. Yes. What about here? Is measured using spring balance. We are using the information to give the differences between mass and what and weight. Then after using the instruments which are used for measuring, we can use them to get the difference between mass and what and weight. Then the other one said that we can differentiate using the explanation what is meant by weight and what is meant by mass. Who can give us what is meant by mass? Everybody. Mass is the quantity of matter and object does what? Contain. Mass is the quantity of what? Of matter and object contains. That is great. What about weight? The other one said that weight is the force of gravity which acts on an what? On an object. Or weight is the force an object exerts on anything that freely supports it. Both are good explanation of weight. We can use the definition. Mass is a quantity of matter and object contains an object contains. Here weight is the force of gravity that acts on an object. And what? An object. We are using the information. We said that if you are to get the differences, read about mass, also read about weight. When you compare them, you can get the differences between the two. Then of the two, one has said that for him, when he googled, checked into the internet, he found that he was told that that mass does not change. That mass does not change. It remains the same everywhere you go. But weight keeps on changing from one place to another, which was a very correct what? Correct answer. Correct difference. Mass is constant, something which does not change. It is constant. So we can use that one, that mass does not change or is constant. Here it is weight is not constant. Is not constant, or we say that it varies. Weight varies. Then we have quantity, vector and scalar quantity. When you checked on internet, you googled, there is somebody who came up with the answer that mass is a scalar quantity. On side of mass is a scalar quantity. These are the answers which I found with you, which were sent the responses that is a scalar quantity. You are very good students. Please keep on doing that. Wherever I give you the assignment, please go to the internet. Internet is one of the source of information social network. Is a scalar quantity, while weight is a vector quantity. Thank you for being a good student. Good students. This one is a vector quantity, vector quantity. That was a very good difference, is a scalar quantity. Good. Then I was surprised when one of your colleague who belongs to senior one of Mbogo mixed SS, he said for him he found out that another difference of the two, there is a derived quantity and a fundamental quantity. That for him he was able to find out that mass is a fundamental, mass is a fundamental quantity, while weight is a derived, weight is a derived quantity. Weight is the derived quantity. These are some of the differences which you were able to submit in from the assignment which I gave you. Now, next assignment which was given to you was to give the reasons or to explain one of the differences between mass and weight which you gave. One of them, which is very important, is that mass is constant while weight varies. It changes from one place to another. Now, our major concern is as a physicist, when you go to the society, and it's, maybe one of our parents may Google that differences between mass and weight, and find that mass is constant, weight varies, but can ask you, why weight varies? Why does it change from one place to another? One, are we saying this? What name is given to this a model? This is a model of the earth. What is the shape of this? Now one has said, I'm saying a circle. Then another one is saying a what? A sphere. This is the one of the shape, the model, the shape of the earth. Which shape? What is the correct shape for this? Good. It is a ball. It looks like a what? A ball. Good. Now, anything which looks like a ball, which name do we give to that shape? It is called a sphere. A sphere. Very good. A sphere. Now, when we design the model of the earth looks like as if it is a sphere. A sphere. It is a what? A sphere. And one of the response which I got from you, you said that earth is not a perfect sphere. As you see this one, it is not a perfect what? Sphere. That one makes the weight of the body to be different. But most of you did not give the explanation. Earth is not a perfect sphere. How does it make the weight of the earth? How does it affect the weight of the earth? From the one of the explanation of weight, weight is the force that pulls an object towards the center of the earth. If you are on Earth's surface, when you move away from Earth's surface, there is a force which pulls you, but that force concentrates at the center of the what? Of the earth. It pulls you towards the center of the earth. Now, the earth looks like it is not. Earth is not a perfect sphere. A sphere is not a perfect sphere. Then another response rotation of the earth. Rotation of the earth. Rotation of the earth. These are very good answers, and these are major two reasons as to why acceleration, the weight of the body changes on Earth's what? Surface. However, you may not be on Earth's surface. You may be on another planet. Different planets have different acceleration due to gravity. Different planets have different acceleration. Different acceleration due to gravity. We have the planet Earth. The planet Earth. Last time we were able to look at the acceleration due to gravity on Earth. And what is that value for acceleration due to gravity on Earth? It is always 10 G is equal to 10. On Earth's surface, G is 10 meters per second squared. Now, when you go to the moon, that value will not be the same. On the moon, the acceleration due to gravity changes. The acceleration due to gravity on Mars is different from that on Earth's what? Surface. Therefore, because we calculate weight, weight is the mass times acceleration due to gravity. Wherever the acceleration due to gravity changes, mass remains constant. Now the weight will change with the acceleration due to gravity. Therefore, the major reasons as to why the weight of the body varies. 1. Earth is not a perfect sphere. Earth is not a perfect sphere. Then another reason, in summary, Earth, there is rotation of the Earth. Then another one, different planets have different acceleration due to gravity. But however, as a physicist, you should be in a position to explain how the Earth not being a perfect sphere and the rotation of the Earth affects the weight. Now we said that this Earth, this is the Earth, is not what? Is not a perfect what? Sphere. There is the equator. This is the equator. This is the equator. This is the Earth's what? This is the Earth's surface. If we compare two children, one whose mother is in Europe, another one whose mother is in Uganda, of the two, where is the attraction between the two great? The person whose mother is in America will have less love for the parent, because this parent is very what? Is very far. But if your mother is close to you, you will have great love to your mother. Now we are comparing love with the force of attraction. If you are close to your mother, the force of attraction is great. But if your mother is very far from you, the force of attraction will be less. Now we are comparing. The gravitational force concentrates at the center of the Earth. When you are at the equator, the distance of the person at the equator on Earth's surface, when you compare that distance, is greater than when the person is on at the pole. Now this is what we try to mean. Earth is not a perfect what? A sphere. Now, because it is not a perfect sphere, this is the shape. This is the center. And this is the equator. We have the equator. Now when we compare, we have a person at point A, a person at point B. It is oval, it is like an oval. If you are at point A, you are very far from the center of the earth where the gravitational force concentrates. If you are at point B, you are very close to the center where the gravitational force concentrates. Therefore, when you compare the person here and there, this one is far, therefore the force of gravity is less. And since weight is the force of gravity which acts on any object, the force of attraction from the center is small because it's very far. But at the pole, the distance from the center of the earth is small. Therefore, the force of attraction towards the center of the earth is great. Therefore, the weight of the body at the equator is less than the weight of the body when it is at the pole. Therefore, the weight goes on increasing wherever you move away from the equator. When you move towards the pole, your weight goes on increasing. So that is how the weight is affected by the shape of the earth. Next, we said the rotation of the earth. The earth has its axis of rotation. So when the earth rotates, anything at the center of the earth, if somebody is at the equator, and rotates with the earth, when we are on Earth's surface, but as it rotates, we rotate with it. It rotates with us. Now the person here, when it is rotating, there is a force towards the center. Then here we create another force which is away from the center of the earth, which is called the centrifugal what? Centrifugal force. Centrifugal force. Now this centrifugal force tend to affect the gravitational force which is towards the center of the earth. Now here, the body will be acted on by two forces. There is the force of gravity which is towards the center of the earth, and there is the centrifugal force which is away from the center. Now this centrifugal force reduces the acceleration, the weight of the body or the gravitational force which is towards the center of the earth. Therefore, when you are at the equator, your weight reduces. What about if you are at the pole? When you are at the pole here, when the earth is rotating, this centrifugal force is no longer there. It is zero. Therefore, your weight is not affected. What does it imply? At the equator, when the earth is rotating, your weight at the equator is smaller than your weight at the pole. So those are the major three reasons as to why the weight of the body varies. One, it varies because of the rotation of the earth, because earth is not a perfect sphere, and lastly, different planets have different acceleration due to gravity. And from that point of view, we can try out this question. We can try out, having got the different what causes the weight of the body to reduce. I can check whether you've understood. The question, calculate the weight of a body of mass 20 kilogram on the planet on the planet where the acceleration are due to gravity. Acceleration due to gravity is a fifth of that on Earth's surface. Is that calculate the acceleration, calculate the weight of the weight of a body of mass 20 kilogram on the planet where the acceleration due to gravity is a fifth of that on Earth's surface. On Earth's what? A surface. So this is your question. I want you to try out this question and be able to get the weight. We said that one of the reasons as to why the weight of the body changes from place to place, different planets have different acceleration due to gravity. Remember, the acceleration due to gravity on Earth's surface is 10. Now use it to calculate the acceleration due to gravity of a body on another planet where the acceleration due to gravity is a fifth of that on Earth's surface. That question is for you. Now, dear senior ones, senior ones, please, can you put your hands together with me? Can you start rubbing? What are you feeling? What are you feeling? Good. What are you feeling? There is one who has said is feeling pain, which is very okay. When you rub, if your skin is is somehow rough, you are feeling pain. Another one has said that is feeling heaty. Very good. Pain, heat, which is okay. Now, let us, I think most of us are not feeling pain, but you are feeling some heat. The temperature has increased. You rub. Are you feeling it heat? Good. There is heat. Now, my question is, what brings about that heat? What brings about that heat? That heat, it is brought about by what? It is brought about by friction. It is brought about by that type of force called friction. So that is great. When you rub your hands, you feel a lot of heat. When you get a stick from a matchbox, you try to rub it, it produces heat. And that heat is due to friction. And now, last time, we explained what is meant by friction. What did we say about frictional force? This is another type of force. It is the one which we have identified that brings about heating effect. So one said that when you checked it through, that friction is the force that opposes the relative relative motion between two surfaces, and the surfaces must be in what? In contact. Do not separate, but in contact. contact. Friction is the force that opposes relative motion between two surfaces in contact. Now we looked at force. We are going to look at force in detail. Friction is the force that opposes, or that one we already know, that opposes relative motion between two surfaces in contact. In what? In contact. Can you outline some of the effects of force wherever there is friction? So effects of frictional force. What happens wherever there is friction? Now let us try out. Rub your hands. Effect, outcome of friction. You say that it is friction which brings about this heating effect. It is the friction, it can produce the unwanted what? Unwanted heat. Another one has said that when a matchstick is rubbed on a matchbox, heat is produced. Which is very what? Very okay. Get your one of your shoe at home. Look at its sole. What have you seen on that shoe? One has said that the sole has reduced. What brings about to that sole to reduce? It is this force called the what? Called the friction. Then another one has said that tearing. When you play gogoro, you find that your clothes can easily get torn. Those are some of the effects of friction. Now we are going to divide those. During your free time, you are going to divide to make sure that you use the outcome of friction or effects of friction to give the advantages and the disadvantages of friction. So questions, outline the disadvantages, disadvantages of friction at your home. That is question 1. Question 2. Mention occasions where friction is of great use. Where do we use the friction? Is friction important to you? Where do you apply friction? Those are the occasions. You can maybe tell us when one is peeling and so on. And number three. If friction is useful, outline the ways of increasing it. Outline the ways of increasing it. Friction is necessary. Maybe in walking, in climbing trees, in peeling, in sharpening objects. Yes, it is very important. How do we increase it? How do we increase it? Another assignment is number 3. Sorry, number 4. Number 4. If friction is of no use, is of nuisance, it has no use. Mention the ways you can reduce it in your society. In your society. Number 5. If your parents car fails to move on a slippery ground, what advice can you give him? Thank you for being good students. For any comment, you can contact me on WhatsApp number 0702325428. Thank you for being good learners.